All right, guys. If you would please find your textbooks, and we are going to turn over to page 75. Okay, we're going to turn over to page 75 in our textbooks. All right, we're going to look at maintaining equality with proportions. Okay, because it's impossible, sorry, let me move that. All right. Because it's impossible to count each individual animal, marine biologists use a method called the capture-recapture method to estimate the population of certain sea creatures. In certain areas of the world, biologists randomly catch and tag a given number of sharks. After a period of time, such as a month, they recapture a second sample of sharks and count the total number of sharks as well as the number of recaptured tagged sharks. Then the biologists use the proportion to estimate the population of sharks living in a certain area. Biologists can set up a proportion to estimate the total number of sharks in an area. And our proportion is right here. Original number of tagged sharks over total number of sharks in an area equals to number of recaptured tagged sharks over number of sharks caught in the second sample. Okay. Although capturing the sharks once is necessary for tagging, it is not necessary to recapture the sharks each time. At times, the tags can be observed through binoculars from a boat or at shore. Biologists originally caught and tagged 24 sharks. Okay, 24 sharks off the coast of Cape Cod, Massachusetts, then released them back into the bay. The next month, they caught 80 sharks with 8 of the sharks already tagged. To estimate the shark population of Cape Cod coast, biologists set up the following proportion: 24 tagged sharks over total sharks equals 8 over the 8 recaptured over the 80 total caught. Notice the variable p is in the proportion. In this proportion, let p represent the total shark population off the coast of Cape Cod. Okay, a variable is a letter or symbol used to represent a number. That's what p is. Okay, so in our problem, that is p. Okay, all right, so let's solve a couple of questions here. Number 1, write 3 additional different proportions you can use to determine the total shark populations off the coast of Cape Cod. All right, so one of the proportions that we can have, let's see here, what's the way I want to start off with? All right, one of them could be this. We could say 24 tagged, okay, over 8 observed, and that's going to equal our P total over 80 sharks. Okay, so that's one way. That's one way. A second way can be this of P total over 24 tagged is equal to, let me make sure I get this in the right spot, 80 sharks over 8 observed, observed, okay, over 8 observed. Piece of 80, 24 is 8, all right. Okay, then it's asking us to estimate the total shark population using any of the proportions. All right, so let's go ahead and use the one that they gave us in the book. Or actually, let's use this one. Let's use number 1. I kind of like number 1. Number 1 looks pretty easy to me. All right, so I'm going to have 24 tag over 8 observe. I'm going to kind of abbreviate, is equal to P total over 80 sharks. Now you're going to ask, well, why did I choose this proportion? Why did I choose this proportion over the others? Well, I can see that I am easily scaling up because I want to know this. So I'm scaling up from 8 to 80. Well, how do I get from 8 to 80? I'm going to multiply by 10. And we know our rules now that when we multiply or do anything on the bottom, we must do the same thing on the top. So I'm going to multiply by 10 on the top. Now 24 times 10, there are many different ways that you guys can do this. So let's take a look. 24 times 10, 0, 0, placeholder, 4, 2, I have 240. So in theory, there should be 240 total sharks in our area. Okay. Number 3, did any of the proportions seem more efficient than the other proportions? Well, we could have gone from 24 to 8, see what 8 times whatever can have gotten me to 24. Okay, let's see, 24 divided by 8. Okay, we could have done this way where 8 times 3 or 24 divided by 3 is this. And then 80 times 3 would have gotten me to 240. We could have used this one, okay, which is the same thing, except if you notice that our sharks and 8 are on top versus here, our sharks and 8 are on bottom. Okay, there's all different ways. So all could have been used to solve the problem. Okay, all could have been used to have solved the problem. All right, let's see. Okay, just trying to make sure. All right, number 4. A wildlife biologist tagged deer in the wildlife refuge. They originally tagged 240 deer and released them back into the refuge. The next month, they observed 180 deer, of which 30 deer were tagged. Okay, so they caught 240, released them. They saw 180, and out of those 180, 30 of them were already tagged. Approximately how many deer are in the refuge? Write a proportion and show your work to determine your answer. Okay, well, let's see. We caught 240 the first time. Okay, I want to know out of the 240, how many total deer are in my refuge? Okay, I caught 240 of the unknown number inside my refuge. All right. Of those 240, when I went to go look again, 30 of them were the original caught of my 180 observed. Okay. 30 were caught of my original 180 observed. Okay. So that seems like a good proportion for me because we don't have to solve. I mean, we can if we wanted to, but we don't have to right now. Okay. Actually, if you want to solve, you can. All right. Number 5. There you go. So a proportion of the form A over B equals C over D can be written in many different ways. Another example is D over B is equal to C over A, or C over A is equal to D over B. Show how the variables were rearranged from the proportion in the if statement to each proportion in the then statement to maintain equality. Okay, so let's take a look at this. So this first one, if A over B is equal to C over D, then D over B is equal to C over A. All right, so if I take a look at this, all I'm looking at, because it's wanting to show how the variables were rearranged in the proportion to maintain, all I need to do is take a look at this is to show that as long as A and D are in diagonal formation, okay, as long as they are in a diagonal, then they will work. And then if I look at B and C, as long as those two are in a diagonal, those are going to work, okay? No matter if I have C on top or C on bottom, so I've got B and C. Okay, so what looks like it happened is that A and D just flipped. Okay, all it looks like is that A and D just flipped positions. C and B stayed the same and A and D just flipped. Okay, all they did was just flip positions, which ends up making this true. Okay, now let's look at the next one. D over B equals C over A. C over A equals D over B. All that happened here is that those two are the exact same thing. All they did was just flip positions. Okay, where this one was second when we looked at the equal sign, and now this one is first. Okay, one was second, and now that one is first. Okay, and number 6, write all the different ways you can rewrite the proportion A over B equals C over D and maintain equality. All right, so I have, let's do this. A over B is equal to C over D. Okay, I can choose this or C over D equals A over B. Just use my flip version. That's what we learned up at the top. Okay, another one I can choose is this. I can choose D over B. So D over B is equal to C over A. C over A. Okay, or C over A is equal to D over B. Another one I can have, okay, I'm going to give you 3 here. D over C is equal to B over A, or B over A is equal to D over C. All right, all of this can look super, super confusing, but let me try and get a couple of highlighters right here, and let's take a look. Okay, if you notice, I noticed that A is equal to C. Okay, C is equal to A. That's always going to be true. All right, so let's look at this next one. I have D over B equals C over A. Now, why can I put D and B together? If you look here in the original problem, it gives me D and B are equal. All right, as long as I either have D and B on the same section, so they're both on the bottom, or as long as I have them both on the same fraction. If I have them both on the same fraction, then I need to see, okay, well, D has to equal something. In my original fraction, D is connected to C, which means when I do D, I have to set it equal to C to make that true. All right? It's all on how you sit there and rearrange it. Okay? But if you guys have any questions, please let us know.